Represent on the same Argand diagram the loci given by the equations z minus 3 absolute value equal to 3, absolute value of z equals absolute value of z minus 2. Then obtain the complex numbers corresponding to the point of intersection of these loci. So basically locus is just the path taken or the path drawn by each of these complex numbers. The path can be a circle, it can be curve or whatnot. So if we want to find the locus of each of these, let's start by writing it down first. Z minus 3 equal to 3. So we can find the equations of each of the complex numbers. So we let z be equal to x plus yi. Okay, substitute it in there, x plus yi minus 3. As you can see, it has only a real part, right? So in this case, we have x minus 3 all squared to get the absolute value plus y, well, it's just going to be alone I, okay? Squared I equal to 3. You square the side as well. This is going to be x minus 3 squared plus y squared equal to 9. And so center is 3, 0. Like I said before, radius is 3. So if we visualize this just for a bit, right? It's a circle with center 0, 3. So 3, 0, pardon me. Okay, 3 on the x-axis. And then we have a circle. I'm just going to have to start from the center. Then I just move this down. Okay. Then I can push this to make a bit of sense. Okay, 0, 3. That's the center. Now, the radius, which is the distance from this complex number, is 3. So the diagram would have to look like this. There we go, from its center. Okay, that's the first Argand diagram. The second would be z minus, so magnitude of z equal to z minus 2. Okay, so again, we let z be x plus yi. Replace these. Magnitude 6 plus yi minus 2. Magnitude. Over here, we're just going to have x squared plus y squared. And then over here, x minus 2, which is the real part. Well, this one is the only one. We add this up, y squared. Okay, expanding these brackets, x squared minus 4x plus 4 plus y. And then here we have x squared plus y squared. And it's obvious that this x squares would cancel. This is a y squared, so it will also have to cancel out. And then we have add 4x on both sides, okay? Just to make sure that this will be 4x equal to 4, x equal to 1. So the locus of this is actually a straight line, okay? Like I said, it can be a curve, it can be anything, it can be a circle. So I'm just going to draw x equal to 1. So if this is 3, 1 must be right over here. It passes through that point. So let's just do it like this. That's the second locus. Next part says, obtain the complex numbers corresponding to the point of intersection of these loci. Intersection of this loci. This is where they intersect, right over here and right over here, right? So we have to get those points. Keep in mind the distance between both of them is 2. So this is 2. Therefore, the hypotenuse should be 3 as well. Why? Because it's the distance from the center to any point of the circle, which is perfect. So if I just extrapolate this would be 3, 2. We have this value which we don't know. Pythagoras is our best friend, so we know that 3 squared equal to y squared plus 2 squared, y equal to square root of 9 minus 4, which is 5. Square root of 5. Okay, so the y coordinate here would be positive root 5. So it means that the point of intersection is when x is 1, we have two values, positive and negative root 5. So that gives us 1 comma root 5, 1 comma negative root 5. There we go. Next question, find the complex number z whose argument is pi over 4, which satisfies this equation. Z plus 2 should be equal to z minus 4. Okay. And they want us to find the complex number z, whose argument. So the argument for z is pi over 4. Keep in mind, argument is practically the same as the tangent. The y over x is the same as the argument of z. Okay, we need to find x and y. Okay, so as always, our z is x plus y, I plus 2 plus I minus 4 plus I, absolute value. So we're going to have x plus 2 squared on this side plus y plus 1 I squared on the other side equal to x minus 4 squared plus y plus 1 squared. Expanding the brackets, x squared plus 4x plus 4 plus y squared plus 2y plus 1 equals x squared minus 8x plus 16 plus y squared plus 2y plus 1. Okay, bringing the like terms together. So x squared cancels x squared, y squared cancels y squared, and we have the x's. So I'm going to add 8x on both sides, and then I'm going to subtract 2y. Oh, it cancels out on both sides. Okay, the 1 as well cancels this 1. 4x plus 8x, which is 12x, plus 4 plus this one gives us 0. So that's it. And then here we have a 16. Okay, I did not see that. Plus this one cancels out 0. Okay, so then 12x is equal to 16 minus 4, which is also 12. So x is equal to a 1. Okay, at least we know x is equal to 1. Now we need to find y. But so remember, I said arc of z, which is the same as tan of the angle, right? It means when you work out the tan inverse of y over x, you should get pi over 4, which is the same as arc z. So let me fix this up. This is supposed to be y over x. That's the correct one. Okay, so let's see. From here, if I take tan to the other side, it's going to be tan of pi over 4 equal to y over x, which is just 1. So then pi over 4, tan of pi over 4 is 1 as well. So y over 1, y is equal to 1. That's good. So definitely z, which is x plus yi, is 1 plus 1i, which is 1 plus I. Question 14. Given that